Welcome to this, the second of a series of 18 lessons that cover advanced customization skills aimed at developers, but useful to everyone who wants to do any customization of Sage CRM, and also very useful to those people working in supporting an implementation of Sage CRM, because it gives you a sense of the architecture of the product and how everything joins together and glues together. We're looking today at entities and the data model. This is a subject that is quite large, so I'm going to be dealing with it in two lessons. And what we'll find is that in this lesson, we're going to be really starting to look at the way in which metadata is used to power Sage CRM. We are going to be touching on a number of different points, really. Some of these are aimed much more for people working with existing projects rather than new projects, and looking at how the Sage CRM has developed over time and left a couple of points that we really need to be aware of as the architecture of Sage CRM changed. So we'll be looking at questions about how data and record identity is handled historically and how it's handled now, but it does mean systems that have upgraded may still be using the old mechanism, and that has an impact on any coding that we do. We'll have a look at a concept of the record object and the SQLQuery object. These are concepts that are used both within the classic COM API used internally within the within CRM, and also within ASP pages and self-service, and then also the .NET API. These use the same concept. We'll look at the question of stored procedures, the appropriateness of use, any problems associated with some of that automatic behavior. We'll look at the idea of what you are allowed to do to your data model as far as customization goes. And we'll also think about the way in which Sage CRM understands and models physical data types into the conceptual types within inside the application layer, and that has an effect on then the presentation layer of the system. We'll use a particular set of examples to take us through the process of adding new tables and fields into Sage CRM, and we'll also look at how we can link to external database tables and understand where all of this information is stored within inside metadata, so that you can start to see that this has a useful element if you're working with support as much as you're working within development. And we'll look at specifically how you can do some clever things without writing any code whatsoever. So that's where we are today. And if we go on to the first of the topics for today's lesson, I want to think about how data and record identity is handled within the product, and we'll look at the record object versus the SQL query object and the role of stored procedures. So these three things we're looking at now. Now, the first thing that I should point out is that Sage CRM uses SQL identity columns, which is a really good, simple way of working, but it didn't always used to be this way. And so although I'm pointing out here, you can find out how SQL identity columns are used in every single table within inside CRM. That's both the application table and also the metadata tables. These are the auto numbering that provides the unique identifier for every record. So comp underscore company ID will be returned as a there as a identity column, comp, and pers underscore person ID as well. All of the primary keys. That's really good. And if we think then into our how that actually transpires, the use of the identity column is something that is within the database itself. But there is a question of what have we used within Sage CRM before. So it changed before version 7.1. Sage CRM used to work in a different way. So it used to use a stored procedure to generate the unique identifier for every record. Now, it did this because it used a disconnected client. There used to be a disconnected client to Sage CRM called Solo. And this allowed for the idea that you would needed to share primary keys across two separate databases. And that meant that the concept of the ID, the identity column, couldn't be used because the external database was of a different type. It wasn't a Microsoft database. So these two databases needed to have a common mechanism for managing primary keys. And so versions before version 7 used to use the idea of a stored procedure called get identity ID to populate the values. Now, this has an impact not so much in code that uses the standard record mechanism, because the standard classes for entering a record within Sage CRM's interfaces will simply accommodate those changes. It only has an impact if you are working with systems that have been upgraded from before version 7. And we do have a lot of customers who have been with the product since early days. Now, specifically, we've got two ways of handling records in code. And this is, I'm not going to go into the code now. I want to raise a question and have you mindful of the need to check code and understand there is a philosophy of design of code that has freedom and consequences with it. So record, which is the mechanism, which is the main mechanism for just inserting a record, we won't have to worry about. But if you're using something called the query object, you will need to be aware of it, because there you are in complete control of how a record is populated, including the primary key value. And the record object is used within classic ASP pages and internal scripts, but it is also used as well inside the .NET API. It has its equivalent there. So this is where we need to check code to see whether it is using the idea of the get identity code. Now, as I was saying, the record object isn't affected. That's the majority of any of the code that you'd be writing. But where you want to be absolutely in control of how a query is structured and composed, then you would typically use the query object. And you'll need to be aware that this has a potential impact on upgrades in and around the validation scripts, table level scripts, other internal scripts, and the ASP pages that you've written. Now, what that looks like when you're working with query object is shown on the screen right now. So in systems that were upgraded from versions of Sage CRM before version 7, 7.1, it would have had this strange declaration of the ret integer variable, the population of that by the invocation of the stored procedure get identity ID to populate the unique identifier for that entity. But if you're working with 7.2 onwards, you don't have to think about, and this is systems that were new from 7.2 onwards, you don't have to think about the use of the stored procedures. But it is important to understand that upgraded systems will still use that old ID mechanism. So just be conscious of that. Now, another thing about the data model and the use of code is when we come on to thinking about um, how we um, how we can use the entities in the objects in the context of security. Now, before I touch on this slide, I just see that a question has come in, which has said, is there any way of altering an upgraded system to use the new method of creating record IDs? Yes, there is. It's out of the scope of this particular conversation, but this has been done, and that's something that we can look at probably with the help of the support teams. It may have to be escalated to Dublin, but it has been done. And that would have an advantage for the long-term support of that particular customer as well. But going back into what I've got on the slide at the moment, which is the use of the question about security, is that one of the strengths of the SQL query object is that you ask any question that you like. So you can create dynamically a query that crosses, not only does it restrict the rows, but it also projects over the columns that you want, including joins onto other tables. You can write freely on any entity that you want, but it bypasses the security system. It bypasses security, so you can't you can't really use this for areas where it is sensitive in terms of the return of data. So the query object will sidestep any aspect of the system security, and we'll be talking more about the way in which any of the queries that we write in the interface then dynamically get changed because of security in the next lesson. I'll be looking quite a lot at security there. So moving on into more of the general conclusion about this is really that we should use the record object rather than the query object for general database interactions. So best practice, use the record object because it manages everything for us, but the query object is very useful in certain circumstances where we have to have complete control of the query that is being asked of the system. And this has an impact on internal scripts, the classic ASP pages, as well as the .NET APIs. This doesn't affect any of the other APIs that we'll be looking at in the course of the training. Going on away from that, think of that first section as something of a warning. We're going to be coming back to looking at all of the APIs in a moment, but everything ultimately is based on what's happening within the database and in the data model. And as we consider what we're doing here, we also now need to think about the allowed database changes and how metadata and physical data types relate to each other. We can create business rules. I started to introduce the concept of business rules in the last lesson. A lot of business rules can be expressed simply by the definition of the correct field type. So if, for example, you are wanting to ensure that a field only contains integer values, then you know you're going to need to select a numeric type, which is only going to allow for integers to be entered. If you want only an allowed range of values to be entered into a text field, then you're going to be looking to create a text field that is supported by a user interface type that allows only a selection to be used on that field. So Sage CRM has this idea of you've got the physical type, we're now going to express rules about the quality of the data that is entered into a particular field by taking advantage of entry types. These are the field types within Sage CRM. So the idea of Sage CRM's interface is to add value all the way through. And the definitions of fields we're going to see in a moment is stored within a table called the custom edits table. And we'll be looking at all of the types that are available to us in a little bit. But if you want to look into the help guide, you'll see that it's called the entry block.entry type in the documentation. Now, Sage CRM, importantly, doesn't use constraints within the database. So you can express allowed values inside the database. You can express minimum and maximum values inside the database, but we don't do that within Sage CRM. That type of constraint is expressed only in metadata. And the only rule expressed inside Sage CRM within the database is in fact whether the primary key is a not null primary key. So that's the only form of integrity that is expressed within the database. All of the referential integrity is managed not within the database layer, but within inside the application layer of Sage CRM. So all constraints within the system are implemented up in the definition of the system. To look out for that is sometimes we get into problems where referential integrity tries to be implemented within the database, and we've had some difficulties with that. So as we move on and we look at a screen, here you can see that I've opened the company summary screen. The company summary screen is obviously a screen that everyone will have seen. I'm looking at here at Eurolandia's data, and Eurolandia is a company which has got lots of different cases and opportunities associated. It's a very good demo company to use. Everything on this screen is a product of metadata. So all the fields, all of the positions of the fields, all the buttons, all the controls, the coaching captions, the control of the buttons on those coaching captions, the tags at the top of the screen, the menus are all controlled by metadata. And there are different versions of the screen defined in metadata depending on the task that is being carried out. So if I switch the screen into edit mode, as though I was editing the information or changing those, then these screens, these fields, then are again shown to us in a slightly different form, but again their behavior originates within definitions held in metadata. Now, if I consider 4 of these fields, we can start to understand how business rules are being implemented in a combination, both the physical data type that's in the database, but also the logical type that is defined within the application layer and then presented to us within the user interface. The first is the company name. We're defining this as a string. It's of a certain length. The amount that you can enter into the field may actually be in the database so long, but we can control exactly how many characters are allowed to go into the field. We'll see in some of the later lessons how we can add yet still further business rules to insist on the correct forms of capitalization within the field, and in fact whether the field is mandatory or not. You'll see there's a little asterisk next to the field indicating that this has to be completed. The next field to look at is the type field. There you can see the rules are defined to say only certain values can be entered into this field. But rather than erroring because an illegal set of characters is entered in, the restriction occurs because of the use of a selection. That selection is defined in metadata as a combination of entries into the custom edits metadata table and the custom underscore captions metadata table, which controls the prompts that are and the values that are allowed to be entered into that field. And if we look at then something like the website, we can see here that the website value that we can put in is going to allow us to enter in a URL, a string of text, which will be transformed on saving into something that we perceive as a clickable link. And the same would go in other fields such as telephone numbers, which would then be rendered inside the Sage CRM interface as a click to dial link. With the last field on this screen, the account manager screen, we can see that this is an implementation of a relationship to another entity. In this case, it's a lookup to the users. And that lookup to the users is an example of a form of referential integrity. You could make this a mandatory field, which would obviously create the rule that a child had to have a parent. But here you can define the parental and child relationship by choosing a lookup to a parental table. So business rules are implemented inside Sage CRM without any code, simply by making use of the correct entry type, which provides the application layer conceptual understanding of the physical data type there where the actual business data is stored. All of these fields are defined inside metadata, and we can look here at the screens within administration customization for the company, and you can see these fields are all defined in different ways. Now, in this particular example that I'm giving you here is that we've got new fields like comp underscore credit agency, comp underscore credit value. Then we've also got some other fields which are defining information about a credit rating, etc. Now, this is an example of customization in practice. 4 new fields have been added into Sage CRM, and those fields then have been edited so that those 4 fields have particular types of behavior associated with them. In the case of something like the credit agency, it's a lookup into the company table to create another relationship between the company and another company. You've got again selections that you can choose which restrict the values. Now, these fields themselves need to be included inside the user interface. And what I've done here is I've created a new screen that is used them so they're called from the interface. Each field will behave in a different way because of the definition. And as I look at this screen, you can see that I've used a mechanism to call this credit check box, so a screen definition, that the fields exist in. Now, I'm going to be looking at where we define new screens in a moment. But this has been used, and I've got 4 separate sets of behavior implementing different types of data integrity and relational integrity inside the system. We are implementing a lot of business logic without doing any coding at this stage. Inside the database, we can see all of these fields are implemented in different ways. So you can see that when we're looking at something like the credit check agency, it's simply an integer field, but it's more than that within the user interface because it has that referential integrity enforced within it. So that field type has a huge amount of value associated with it. Now, as we'll see a little bit later on, and as you explore how we add fields of our own into the interface, the relationship defined within the field type can extend to the point that it's not just a lookup to another table. You can change the way in which the lookup works by filtering the data that is returned in the lookup. And when we come on into the next lesson, we'll also see how any filter that we might have applied is going to be further filtered automatically by Sage CRM because of the automatic change of any SQL issue from the system to take into account the security rules that the system has had implemented within it. So Sage CRM is a system that relies on the idea that we might have particular physical data types like the check date, but it's going to work that has an impact on how it works within the interface. So a lot of add value, like the calendar button, etc., for the date, will be rendered as well. What it means is that you've got a narrow set of physical data types within the database: int, nvarchar, date time, numeric. I think that's it, ntext. So you've got a limited range of field types that might be implemented inside the system, but inside CRM, you've got a very wide range, a much wider range of entry types, which are adding the value on how that field type should be enhanced as it presents to the user inside the user interface. I wonder if there's any questions there from what I've said. Okay, well, I've talked there about the concept of metadata and how it changes simply the interaction with the database and the database tables. We've got to build on this to start to understand how and where table data is stored within metadata. In the early diagrams that I was showing you in the last lesson, all of the interface is dependent on metadata. Every single screen that you see comes from information that ultimately sits inside database tables that are then used to control how screens should be displayed. The next screen that we're looking at is going back into our company summary screen. This is a screen that we're very familiar with. Now, I've changed the presentation of the screen to allow for this time the URL to show at the top of the screen. So what we're looking at is something that looks like this. So you've got the server address, the implementation of CRM, the eWare DLL, and then you've got these name value pairs going through into this. So you've got a lot of contextual information in terms of what's the system action being called there. We'll be talking more about system actions later on in the lessons. We've got the concept of the mode. Typically that's, am I viewing the information? Am I editing the information? And then you've got the contextual information about what's there. I've been asked a question around the difference between intelligent select and search select advanced. Michelle, I'll try and answer that at the end. There are some articles on the newly named Sage Community Hub that do discuss the types of lookups that exist. The intelligent select can be thought of as a filtering selection list. So you've built a list of options that you select down to dynamically, and then the search select advanced is a dynamic relational search up to a parent entity. So it is, they can have the same effect in a way, because something like the user select is a form of intelligent select, but you can build your own intelligent selects. I possibly haven't explained everything about there, but there are articles on Sage Community Hub that I've written that do expand on that. Going back though onto this screen, we see that the screen is a product of we see that the screen is a product of this URL call. How it works is the user makes a request. So we have any screen is a result of a request response cycle. So imagine we as a system administrator has gone into the system and we're looking at metadata tables. Those metadata tables that are associated with, say, the company box long allows us to say, what are the fields from the underlying database view that we should include? And what is the order of those fields? We may also add in some other behavior that controls whether this field is read-only or whether we want it only to be accessible by a particular team within the interface. And so that results in our ability to control not just out-of-the-box screens for company, person, etc., but the same concept applies to any table that is modeled inside metadata. So we'll find that our custom tables work in exactly the same way. Now, in the case of some system actions like this, the screen is made up of a number of calls to metadata that invoke certain structures in the screen objects. The principal metadata object that describes the larger containers like lists and screens is called the screen object. In the case of a system action, though, there are some hard-coded elements. So this company summary screen, for example, can't be broken up into, and you can't decide that you don't want to display a particular field, or you can't add another screen. You can't add another screen into this. So it's a product of very much an entity view of looking at this. Now, our company box, this system action, which happens to be system action 200, the company summary system action, calls company box long, address box short, and person box short. In turn, each of these is defined in metadata, and we can control the fields inside that. Those fields that sit inside the company table can be altered in any way that we like. We can invoke to include them into the company screen and the company tab. So this is where I'm calling the summary, and it's in the tab group, and it's calling the internal system action company summary. If this was calling an ASP page, then it would be calling a slightly different mechanism to call the custom code. And we'll be looking at those later on, how we add in our own structures into the interface. But this model of everything ultimately sitting on the basis of what are in those custom tables, like custom database, custom table, custom edits, custom captions, custom screen objects, custom screens, custom lists, ultimately builds the interface that the users use. We can do a lot of very dramatic changes to the interface. But it is worth reminding ourselves about how Sage CRM works and how it assumes that it's going to work. So problems will occur if anyone carrying out customizations includes database constraints or foreign key constraints or any other range check, for example, within inside the database. This is because Sage CRM, when it is saving records into the system, does not expect any other ancillary check within the database. If you have got something like a database constraint defined, you may well find that Sage CRM simply chokes on it and dies. It will return something like a 500 error, indicating that the page can't process, because it's not expecting to find anyone putting in something like a foreign key constraint directly inside the database. So when we're holding data within inside the database, we know that we're going to be storing all sorts of information inside the system. That's all held in structures that we access through, and when we come to our own customization, through objects. Screens ultimately are dependent on views, which form this concept of a record object, or a more rarely a SQLQuery object. We can think of this in terms of always working with the record object. Now, a single record does tend to only look at a single table, because you're pulling back and expecting to be able to edit that, but there are certain times in which we will project over other tables as well. There are specific occasions when that takes place. Normally, when we're working with something that is returned in terms of a business record, everything comes back as a single row. But there are instances within the data model where the data, the conceptual understanding of a record, is actually multiple rows that are being returned. So there are some instances of data sets or rows coming back that cross multiple rows of data. So examples of this would be user preferences, custom sys params, and then you have some horrible examples like key attributes. I say horrible examples, they are quite hard to be able to model. So this is a diagram of the key attributes relationships and how additional marketing information can be held associated with any record within the system. I'm not going to be covering key attributes in this lesson. I'm not entirely sure that they crop up in other lessons as well. If we look at the way in which data sets progress, we're going to look at the way in which we use metadata, assuming the data is returned as a result of a single row returned by a query. Most screens that you are able to edit, or all screens that you are able to edit, will have been associated with a single row of returned data. So these would be things like the company box long, the address box short, the person box short, which all make up the structure of the company summary screen. You will need to take some advice and preparation if you're coming to edit structures which do not return a single amount of data in a single row. So those are where we're returning something from the user preferences, which is the user settings table, or the phone and email table, or the custom sysparams table. And of course, as I said, the key attributes. We're not going to rush to include that, but I will be mentioning those a little bit later on in the training. But let's take a step back and look at the idea of data coming in from a table. Now, in this particular case, we can see that I'm looking at a completely different database. This is a list of customers inside the Panoply Tech database. So I've got a list of data inside this database, and it's inside a table called contacts. So the database is Panoply Tech, the table is contacts. In Sage CRM, I can go into the customization area, so into administration, advanced customization, and there's the option to start to define the connection through to a database. And so I can choose the tables and databases option, and I can define a new database connection to that external third-party database. Now, if I connect to a database, and watch out, this screen is probably going to be simplified in 2024 R1, but we are going to still be able to connect through to the selected database that we're interested in, providing the connection information, saving that, and we can now add an individual table connection into the system by filling in the fields that we want, looking at the table name, the caption, how it should be known, confirming the database and confirming the primary key value that's being used. And what that will have done by now is created some records inside metadata. It's modeled the connection to the custom database and to that custom table. So far, we don't know anything about the fields unless Sage CRM can infer some behavior. And in fact, what that's doing, that external table connection, is going to allow Sage CRM to make some basic understanding of the table if we then want to use it. Immediately once the connection is made, I can use the record object in code to be able to access that external information. I could create other structures like views which join onto that table to be able to access it. But let's see. If we are defining a structure inside metadata, each of these tables will have a unique identifier. So they get, because we're having to build relationships, the tables themselves will have an entry inside there, and that, especially when we are associating information with a table and then a record within that table, we need to be aware of the fact that the modeling of which table is involved is held inside metadata. An example of where this is important is the notes table, because notes can be associated with not just the company and person, or they can not just be associated with the company, but they can also be associated with a person. They can also be associated, you can make them associated with other entities like opportunities, etc. In which case, in saving the record into the notes table, it has a two-part key. It needs to know what type of table it is and what the unique identifier for that table is. So the board_table ID is used in a lot of cases within Sage CRM to help structures understand that this record is associated with this table and then this record within that table. I have defined at this point a connection to contacts which exists in another database outside of CRM. I am using the idea of metadata to be able to model it. As soon as that connection exists, it appears in the customization area within Sage CRM. I can now go in to look at the fields. Those fields will all have had a physical default interpretation and representation inside Sage CRM. So those fields, for example, you look at that and suddenly you know that a particular field is going to be interpreted as a text field within the interface. Another field is going to be an integer, or it's going to be a date. Depending on the information that is held within inside the database, the physical data type will be mapped onto a default entry type. But we can change this. We can change this to whatever we want, and you can see that I've added in a selection list here, and I've changed one of the fields into www.url, etc. So I can make changes in metadata, and this is changing not just the edits table, custom_edits, but it will also change the custom_captions table. So I'm changing translations, I'm changing the rules and the way in which this field will behave inside the metadata. You can start to see that exact case here. So in custom edits, this is it deciding how the field should display, how anything should look. I can take the idea of all of those custom fields and now use them inside a structure like a list. So I can construct a list. Come in here, you can see I've come into the contacts and I'm starting to create, I've moved on to the lists tab, created a new list, and I'm starting to enter the details, and I'm going to add then all of the different fields as columns into that list. And I can define different properties as to whether the field is searchable, is orderable, etc., and whether it has a caption, etc. Now that I've done that, within the advanced customization area, I can go into the system tabs and choose an option to go and select the menu that I want to add this list. And I happen to know that it will be the user list, which is the My CRM menu. Within this menu, I'm going to use a feature known as run block. Now, that was the very first API option that we looked at in the last lesson last week. So run block is a way of calling purely metadata-driven customizations. So I'm using metadata here to invoke the list block that has contained the fields that are mapped on to the contacts table in the external database. The option can be called then from the My CRM menu once it's been saved, and this is how it will look. It pulls the data from the external system. Now we've only displayed and listed out data here, but it is possible to take this use of metadata further to create not only view screens, but view and edit screens. And it's even possible to go still further and to add in insert screens as well, all on an external table. Now, how that fits into CRM? Well, that would have to develop a little bit further. You'd have to think about how do you relate the external information to Sage CRM. In fact, what are you going to do with it? You might want to look up into an external system and then select promote into CRM in order to create, say, new leads, or if these are work orders, you're just selecting and pulling in tasks for a team inside CRM. So this is at the very simplest level of where you can integrate into Sage CRM. So this is all this extensibility architecture, and the area that if I highlight now, just by highlighting this is what we've been looking at, the third-party database being able to be modeled with metadata in order to extract the information. Now we're going to take this a little bit further. Certainly in the next lesson, we're going to be looking at the idea of how we can extend the information in any one particular field, in any one particular screen or list by the use of not just connection to a table, but to a view. We can take that still further. We can understand that when we're looking at our entities within the system, we're going to have to think about much wider senses of definition of what that structure is. Now, our special concern will be over tables that have been added into Sage CRM to extend its core behavior. And this is the idea of custom entities. We'll be looking at how they get created, whether that's through the advanced customization wizard, in which we will get stub security and workflow created for us, but plus the ability to work with merge and communications. We can look as well, and this is really what I've done here, which is the idea of creating a table via the interface, where we become much more of having to think about how we manage the whole question of what type of entity it is. It tends to be called a primary entity if it has security associated with it. So if we don't make use of security, so sec underscore ter, or we don't make use of workflow, then it's not really a primary entity as such. Now, we can also link, as you can see there, to an external table. But when you're doing that, because it's an external table, if it's got no relationship to an internal structure, then it's always going to be considered to be a secondary table. There's no security and no workflow associated with these. There are ways in which, if you create a link table so that there is a corresponding record within inside Sage CRM to that external table, then yes, you could effectually workflow the external table. Okay. That external table that I connected to, does it have to be a table? Well, no. I've actually looked at how we can, there are articles as well of how you can connect to views. So you can use external information as views. You can also theoretically connect to a stored procedure. So you can connect to, say, select star from the stored procedure, or you can select whatever from the stored procedure. And if that stored procedure is set up to return particular columns from a complex query, then you can do that as well. So what you can connect to is really quite sophisticated. In Sage CRM, we use the concept of endpoints that are actually web RESTful points, and that's used as what's called the real-time data views. And it is also possible as well. Again, this is something that we've done within our teams to set up web services as tables. It is possible to do that. Not so easy and not something that I would recommend really. When we look on to what we've got, you can see here that I'm connecting through to an external view in this last thing, but we are now at the end of the lesson, and we're looking forward into the next set of behavior, set of things to consider. So in our next lesson, what I'll be looking at is I'll be starting to think about how views are structured, how we start to access information across multiple tables, build structures on those, how Sage CRM changes dynamically the SQL that is generated from the interface, and more about the relationship between entities and this data model, business entities, the structures that we see within the user interface and the underlying data. So I'm going to come on to the questions now. Let's see if anyone's got any questions there. If there's no other questions, I'm going to say we've done this within the hour, which is what I wanted to do. But thank you so much for enduring another session with me. I hope it has been useful, and I look forward to seeing you next week. Thank you. Bye-bye, everyone.